With the primary standard calcium carbonate sample, you will prepare a solution of calcium chloride, a standard solution. This will begin by adding 50 milliliters of deionized water to your calcium carbonate standard. To that mixture, you will add 6 molar hydrochloric acid until effervescence ceases. A chemical reaction occurs between the calcium carbonate and the hydrochloric acid, producing carbon dioxide gas. Initially, you can add full pipettefuls of the hydrochloric acid, but as the solid begins to disappear considerably, all the calcium carbonate will dissolve. You want to slow down your delivery of hydrochloric acid. Adding too much acid at this step will hinder your abilities to adjust the pH later on in the titration, so you want to very carefully add that so you don't have too much of an excess. In fact, you want to maybe keep track with how much acid you're adding from a graduated cylinder to ensure for the primary standard that you do not use more than 15 milliliters of the 6 molar HCl. Swirl with each addition, but don't stick anything inside of the beaker because you don't want to lose any calcium ion. Okay, at this point it looks like there's no more gas bubbles being produced. Okay, and I haven't added more than 15 milliliters. Next, due to some carbon dioxide gas being trapped, that too would hinder pH adjustment later. You're going to boil that away. You're going to cover your beaker with a watch glass, and you're going to place this on a hot plate and boil for 2 to 3 minutes. Once the boiled sample has had a chance to cool, you'll notice the condensation on the underside of the watch glass. You want to rinse that back into your beaker. The best way to do that is to very carefully lift up the watch glass right over the mouth of the beaker, and then use your wash bottle to rinse all of that condensation off back into your beaker. The next thing you want to do is to dilute this calcium mixture to a known and exact volume. We'll use a volumetric flask for this, and this standard solution will be diluted to an exact 1,000 milliliter volume. You want a good quantitative transfer of the solution that's in the beaker into that volumetric flask. Best way to do that is to put a funnel over the mouth of your volumetric flask, and then you want to make sure that you rinse out all of the calcium ions that's in the beaker and transfer those rinsings through. So using your wash bottle, you'll rinse the beaker, pour those through, rinse, 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 rinse. I would rinse at least 4 to 5 times. After rinsing enough times, you then want to very accurately dilute the solution to the 1,000 ml mark that's on the neck of your flask. You can add water fairly quickly until you reach the neck of the flask, and now you want to kind of slow down your delivery of water. You can also use a pasture pipette here, but the key is to not exceed the line that's on the neck of the flask, and you should be watching this at eye level, just like you would read a burette. And then when the bottom of the meniscus is exactly on that line, read at eye level, you have your solution diluted properly. And now to have a well-mixed solution, you want to mix solutions in volumetric glassware through a technique known as inversion, turning it upside down, right side up 3 or 4 times. Okay, so this gives you a accurately prepared primary standard calcium chloride solution.